The Internet, where did it come from, and how does it work? The Internet is the world's largest wide area network. It is a fault-tolerant and scalable network made up of hundreds of thousands of individual computers, servers, local and wide area networks, both public and private. But how did we get from the punch cards and mainframe computers of the first half of the 20th century to the ubiquitous cloud computing Internet that we know today? We're going to take a quick look. I've broken this little presentation out into 4 sections. First, we will look at the origins. Where did it come from? Then we will take a peek at the communication protocols and the architecture that makes up the Internet. Finally, we will explore how the Internet differs from the World Wide Web. When the Soviets launched Sputnik into space on October 4th, 1957, they unleashed a fear in the US government, and the space race was on. 5 months later, the Advanced Research Projects Agency was launched. ARPA, ARPA, was changed to the Defense Advanced Research Projects Agency, DARPA, DARPA, in 1971. Then they changed back to ARPA in 1993 and back to DARPA again in 1996. Just imagine how much money was being spent on stationery and rebranding. The 60s weren't all love, peace, and psychedelics. It was also the beginning of the Internet of today. Many characters have been involved in creating today's Internet. There are too many to include here, but some individuals played a more significant role than others. In 1961, Leonard Kleinrock pioneered the concept of packet switching in his MIT doctoral thesis. This is an important foundation to the protocols that we're going to look at in a moment. A year later, Joseph Carl Robert Licklider, known simply as JCR or Lick, became the head of the computer research program at ARPA. Lick was an American psychologist and computer scientist who is considered one of the most important figures in computer science and general computing history. The same year that he joined ARPA, he shared about his intergalactic network concept with some of his colleagues in a memo. While there are many important projects that happened during this time, another significant milestone was in 1965 when 2 dudes, Lawrence Roberts from MIT and Thomas Marl, got a contract with ARPA to create the first wide area network, a WAN, which was a connection via long-distance dial-up connection. That connection was between a computer in Massachusetts and a computer in California. This was the first wide area network system that confirmed that packet switching offered a promising model for communication between computers. Then in 1966, ARPA Director Charles Herzfeld approved funding to develop a networking experience that would tie together multiple universities funded by the agency. The result would be the ARPANET that was launched under Licklider's watch, and it was the first packet network and a predecessor to the Internet that we know today. Protocols are a system of rules or official procedures that provide for an acceptable way to do things. We use protocols in many different aspects of our life, including in business and government, during ceremonies and a number of different events. Just as we abide by many different protocols in our society, in technology, a protocol is a collection of rules for formatting, ordering, and error-checking data that is sent across a network. UCLA developed the host protocols for ARPANET and became the first hub or node to connect. Other educational institutions soon followed. The original use of this now identified Internet was for government, academic, and research purposes. At the same time, educational institutions were beginning to join in. Vint Cerf, who was also working at DARPA, and Robert Kahn, who was from Princeton University, they collaborated to develop the communication protocols that were necessary to allow the radio, satellite, and telephone network communications to begin communicating together. They were all using different languages, but they developed a communication protocol and the networking technology that laid the foundation for the modern Internet protocols that we use today. Let's take a deeper dive into what that is, known as TCP/IP. You might be familiar with the idea that computers process binary units, zeros and ones, with each particular combination of bits representing a certain alphanumeric character or a simple mathematical operation. 8 bits are needed to represent any given character. An 8-bit string of zeros and ones is known as a byte. All the information on the internet, such as email communications, a website name, all of it is data, and it's all made up of many, many bytes. So what is packet switching protocol and how does that work? TCP/IP, Transmission Control Protocol, Internet Protocol, is the standard communication protocol for the transmission of data on the Internet. This protocol is responsible for establishing a connection between computers, dividing the bytes of data into small packets, little tiny deliverable parcels, and then it sequences and transfers those packets or little parcels of packets and delivers them to the intended destination and ensures the reassembly of those packets into correct and complete packages. Connections between computers therefore need to have a unique address, just like we have unique addresses at our homes. This is an established with what is known as an IP, the Internet Protocol numbering system. So every computer, every device connected to the Internet has its own IP address. Every device on the Internet has a unique IP address, whether it's your computer, your iPad, your cell phone, your iWatch, your printer, your smart TV, or a smart refrigerator, anything connected to the Internet. At the beginning of IP addressing, the Internet was not very large and is nowhere near as large as the commercial sensation that we know of today. Most networks were private and closed off from other networks around the world. IPv4, version 4, that's the original numbering system. It was developed to use 32 binary bits, 32 characters, to create a single unique address on the network. An IP4 address is expressed by 4 numbers separated by dots. Under IP4, there are 232 possible combinations of the number sets. With that combination results in just under 4.3 billion unique addresses. But when the Internet exploded, it became clear that 4.3 billion IP addresses might not be enough. And sooner or later, we're going to run out. So IPv6 was then created, and that raises the potential to 2,128 possible numerical sets for each part of that address. So that results in an undeterminable amount of address possibilities. As a simple recap, the Internet kind of works like this. A client computer makes a request via a browser. The browser sends the request via the hardware connections, so from your IP address to the terminating IP address. Some routers in the middle will look up the IP addresses and provide directions. The request then travels to the terminating server or host computer and delivers the data. Maybe a web page, maybe some search results, maybe it's a song, maybe it's an email, whatever. But it sends all that data sent back to the requesting client computer via the browser. The architecture or the infrastructure of the internet, is all of those pieces of hardware and all the software and connections of the world's largest wide area network. While the protocols of the internet have not changed, we have come a long way, baby, when it comes to computer hardware and software. Let's look at the architecture or the infrastructure of the internet. Networks are made up of computers. Some are faster, some might be slower, some have more storage capacities than others. Some computers have a specific role of being a router. They receive packages of information, they consider the IP address that they're going to, and then they send the packets on their way to the destination. They literally route the packets of data from one place to another. Other computers on the internet within the infrastructure are called servers. They host up, they host and then they serve up all the information such as a web page or a domain name. All of these computers have a variety of software applications that enable them to do their jobs. And of course, all of them are connected, either hardwired or wireless connections. So they are all connected to the internet. So what is the World Wide Web and how is it different? Well, the World Wide Web refers to the information sharing model that was built on the internet. So the internet is the world's largest wide area network. The World Wide Web is that sharing model that was built to take advantage of that wide area network. It's a system of shared standards that includes hypertext markup language and hypertext transfer protocols that links web pages and websites together. And all of those pages, of course, are accessed via a web browser. We're not going to go into this World Wide Web too much further today. We can go off into all kinds of segments. So for now, let's just suffice to say that the World Wide Web is simply the information space in which the items of interest, referred to as resources, are identified by global identifiers called the Uniform Resource Identifiers. Thus, the web is an information space. The first three specifications for web technologies are defined URLs, Uniform Resource Locators, HTTP, which is a Hypertext Transfer Protocol, and HTML, the Hypertext Markup Language. All of those are still in use today. There is much design and structure behind the ubiquitous technology that we seemingly could not live without today. Now that you have a foundational knowledge of what the internet actually is, we will be visiting some of the components in our classes this semester. There are a few activities for you to do in the text on this web page below the video. You can take a deeper dive on any of the topics covered. Here are some good links to get started. I do look forward to seeing you in class.